we go. All right. Okay, so 5.1 talks about something called normal distributions and the standard normal distribution. And so it says here in chapter 4, we discussed discrete and continuous random variables, and in 4.2 and 4.3, we talked about discrete probability distributions such as the binomial, geometric, and the Poisson. Here in chapter 5, we're going to work with something called continuous random variables. And it says, recall that a continuous random variables can take on an infinite number of possible values, and continuous probability distributions are created to reflect those possibilities. And it says the most important continuous probability is what we call the normal distribution. Okay, so let's see what we have here. It says the normal distribution is a continuous probability distribution for some random variable x. It says the graph of the normal distribution is what we call the normal curve. A lot of times people refer to it as the bell curve. You may have heard that before. So let's see. Normal distribution has these properties. So number one, the mean, median, and mode are all the same. The normal curve is bell-shaped, hence we call it the bell curve, and is symmetric about the mean. So you can see here in the middle, let me get my pen going. Here's my mean, right? Let's see, the total area under the curve is equal to 1. This is important. The normal curve approaches but never touches the x-axis as it extends further and further away from the mean. So what I mean by that is this graph here gets close and close and close and close and close, but it never actually touches, whether I'm going to the left or whether I'm going to the right. Okay, it gets really, really close. And we call those things, in algebra, we call them asymptotes. It's going to be the same thing here. Let's see. Number 5, it says between mu minus sigma and mu plus sigma, the center of the curve, so this piece right here, the graph curves downward. And then the graph curves upward to the left of mu minus sigma and mu plus sigma, and these are what we call inflection points. So they're saying right here, the graph is going downward. And then as I pass that point, the graph starts to curve up. And I mean, the graph is going down, but it's curving up like this. So sometimes people say, I heard this years ago, concave down looks like a frown, and concave up looks like a cup, right? So if you look from here, this is kind of like half a cup, right? And if you look here, this is kind of like half a cup, but this piece right here looks like a frown, right? Because it's concave down. Okay, so that's what that's telling me there. And then I'm going to give you some more information and we can figure some stuff out. It says discrete probability distributions are graphed with histograms. However, continuous probability distributions are graphed with a probability density function where the total area under the curve is 1. Excuse me, it says a normal distribution can have any mean and any positive standard deviation. These two parameters are actually what shapes the distribution. And the mean gives the location of the line of symmetry. And the standard deviation is what we call the spread of the data. Okay, so let me show you an example here. And I like these problems because I think they give us a visual of what's going on. Okay, so number 1 says match the normal curve with its parameters. So here's my first problem. It's this piece right here, and we want to see if we can figure out some parts. So remember, the mu is what we call the mean, and that's the center of the graph, okay? And then this here, the little, looks like an O with a little hat. Excuse me. That's my standard deviation. Oops, standard deviation, and this is what's given me what we would call the spread, okay? So first thing I'm going to do here is I'm going to look for mu is equal to 3.5. So the median, the center of my graph is going to be at 3.5, right? So I notice that both choices A and B are right here in the middle at 3.5, right? But one of them has a spread of 0.7 And the other one, if you look right here, guys, F is the mean is 3.5, but look at the spread here, it's 1.5. So what that tells me is that A and B are either going to get matched with one of these two because they have the same mean. But the one that's spread more out would be this one here, right? So if I look at choices A and B, which graph seems to be more spread? Well, A seems to be more spread, right? So this one here would match up with that one, and this one here would match up with that one. And then that tells me that this one here, look at the mean, 1.5. And if you look right here in the middle, there's my 1.5. My spread is very narrow as well. It's only 0.7. So that graph is going to get matched to that. Okay. All right. Now, let's take a look at number 2. Guys, the other thing I want to mention, as I'm going through these problems, at any point in time, if you have a question or there's something you don't understand or something didn't seem to make sense, please let me know and I'll be more than happy to go over it again, okay? I'm here for you guys, so if you got questions, let me know because that's why I'm here. Okay, so now number 2 says, answer each question below pertaining to the following normal distributions. It says, which normal curve has the greater mean? Which one has the greatest standard deviation? Which two curves have the same mean? And what's the mean for the curve of B? Okay, so remember what the mean is. The mean is going to be the center of the graph. So here's the center of this graph. This looks like it's about 45. And the center of this graph looks like it's about 60. So which graph has the bigger center? Well, I would say B does because the center is centered at 60, right? So this would be B. Now, part B here, little b, says which graph has the greatest standard deviation, meaning which is the one that has the biggest spread. The one that has the biggest spread would be C, because look how spread out this graph is, right? It's spread out more than A or B. So C would have the one that has the greatest standard deviation. Okay. And then, let me clean this up a little bit. Which two curves, oh, come on, pen, have the same mean? So here's the mean, right? These two curves have the same mean, A and C. And then what's the mean for the curve of B? Well, we already said the mean here was 60. Okay. All right. So now there is a part 3, or a third part, or yeah, number 3 on this question. And it says, what's the mean weight and the standard deviations for all newborns born in the U.S. in a recent year? Okay, so remember, the way we're going to find the mean weight, we're going to look for the center of the graph. So the mean weight is 3,300. This is in grams. Okay, and now we want to find the standard deviation. So what I'm trying to find here, guys, is these points right here, where the graph kind of changes from going down. So like right here, it's going down. And then right here, the graph goes up and the graph goes up. We're looking for, here, we're looking for this, say this distance right here, okay? Or this distance right here. So this is 2,700, this is 2,100. Oh, I don't know, I'm gonna make this up. I'm gonna say this is about 2,600, okay? And if this distance, if this value here is 3,300, I want to find the difference in those. So I'm going to take 3,300 minus 2,600, okay? And that's going to give me approximately 700 grams, right? Now, guys, remember, I'm estimating here, right? So if you would have said, well, it looks to me more like 2,500, then you would have come up with 800 grams, right? Something like that. But you obviously you wouldn't say it's really close to like 9, because it's not nowhere close to 9. The idea is you're going to take a guess, and you're going to take what we call like a good guess, an educated guess, right? Okay, so now number 4, we're going to do exactly the same thing. We want to find the mean, and we want to find the standard deviation. Okay, so remember, the mean is going to be the center of the graph. So I'm going to come right here. Boom. There's the mean. It's not exactly at, maybe it is. Let's see. Yeah, it's not exactly at 650, and it's not at 660. So I don't know. I'm going to roughly estimate 655, right? Now remember, I'm going to find those points where the graph kind of changes here, right? This is when it's going down. And I'm looking for this distance, whichever one you want to use. It's up to you, right? So because this number here is 680, I'm going to use that value. So I'm going to take 680 minus 655, and that's going to give me 25. Before I go on, are we making any sense of how I'm kind of going through these problems so far? Are like 1, 2, 3, and 4, are those problems making any sense?
Yes, they're making sense.
Okay, Perla, you have a question? I saw you have your hand up. Perla, can you hear me? Or were you just saying they're
Yes.
good? Yes, ma'am.
I just wanted to make sure that it's just an approximate average for the
Yes.
estimated number in standard deviation. It can go either way.
Yeah, so whether I use, let me come back to the notes real quick. So so remember this number here we said was about 655, right? So if I come down to this one, if that's 620 and that's 640, this number here would be, what, 630? So if I were to say the same thing, let me find the distance between those two, and I would take 655 minus 630. I'm still going to come up with 25, right? But you're right, it's an estimate. Like I guessed this number here to be 655. The idea is when you're doing this on my lab, there's something, guys, that they call a tolerance. And what they mean by a tolerance is like, I came up with 25, but if you would have come up with like say 23, or you would have come up with 27, 23, 24, 25, 26, 27, you would get credit for it, right? But if you came up with something like the difference between those two numbers is 700, then obviously it would be really way off. But yeah, you're going to have a little leeway there. But you're right, it's a guess, right? The way we're doing these problems right now, they're basically a guess. So excellent questions, guys. At any point in time, as I'm going through the stuff here, if you have questions, please interrupt me. I don't mind. I prefer it so that you can make sure that we're doing okay. All right. So I'll tell you what. Let's do this one here, and it's the same type of problem. And it says, what's the mean on the normal curve? And then, very good, like Perla said right now, guys, estimate the standard deviation. So you're right, it is an estimate. So by looking at the graph, I'm sure we would say, well, the mean is 52. And, and my inflection points seem to be right about there. So whether I'm looking at 40 or whether I'm looking at 64, I would do this the same way, right? What's the difference or the distance between those two numbers? 52 minus, my pen freezes sometimes, guys, so I have to hit it, would be 12, right? That would be the distance. And whether I did it this way too would be the same thing, right? 64 minus 52, I'm still going to come up with 12. All right, excellent. Okay, so there's something called the standard normal distribution. And it says the reality is that there's a bunch, infinitely many normal distributions to represent infinitely many situations with infinitely many means and standard deviations. And the normal distribution with a mean of 0 and a standard deviation is 1 is what we call the standard normal distribution. So I want you to look at the picture here. And if we say, look, what's the mean? The mean is 0, right? And what's the standard deviation? The standard deviation, the difference between this space here or that space there is going to be 1. This is what we call the standard normal distribution, okay? And what we do with this, guys, is that we can take problems and convert them to a standard normal distribution and then we can find certain pieces, okay? So it says, recall that a z-score for a random variable x is a measure of position that's indicated, that indicates the number of standard deviation the value lies from the mean. So here was our z value, right? And it says when each data value of a normally distributed random variable x is transformed into a z-score, the result is what we call the standard normal distribution. And it says the cool thing is that the area falls under that non-standard normal curve is the same as the area under the standard normal curve with the corresponding z values. And the empirical rule helped us determine the area under the curve for values that were 1, 2, 3 deviations from the mean. And we're now going to examine finding the area under the curve for all the values of the random variable x using the standard normal distribution, which lists the cumulative area under the standard normal curve to the left of any z-score from negative 3.49 to positive 3.49. Okay, so let's see what we can figure out here. It says the cumulative area is close to 0 for z-scores close to z equals negative 3.49. Okay, what we're doing, guys, we're finding the area under the curve, and we're always finding the area from the left to the right. So they're saying that if you're over here at negative 3.49, so look, there's negative 1, negative 2, negative 3. If you're all the way over here, the area underneath that curve is really close to 0. And as we start to move from the left to the right, we're finding the area. And that area is getting bigger and bigger and bigger because we're finding the area all the way, right? And it says the cumulative area for z equals 0. So we were just going to find the area of this piece right here from 0 all the way to the left. That's going to be 0.5. Okay? And as long as we keep moving more and more and more and more to the right, the area is going to get really, really close to 1. Okay? Because we're finding the area, again, as we go from the left all the way to the right. So let's see if we can figure something out here. And it says, using the standard normal table, find the cumulative area that corresponds to a z-score of negative 1.25. Okay, so I'm going to show you 2 ways how you can do this, guys. Here is my z value, negative 1.25. Negative 1.25 would be somewhere right about here. And when we're doing this, again, we're finding the area to the left of that value, okay? So, you know what? I don't know if I put this in your, I meant to, and I don't know if I did. And if not, I will definitely upload it so that you guys can find this. And I'm afraid to say that I didn't do it, but I'll upload it so that I can show you how to do the stuff. So I'm going to use something called the standard normal table. So let me get my notes real quick. Let me see if I can find it. What is it? What is it? What is it? What is it? Here we go. Yeah. Okay, so guys, I think I'm going to upload this because I don't think I did earlier. So I'm going to show you how I can do this using my table here. So I'm going to stop sharing this screen with you guys, and I'm going to share a different screen with you all. Right here. Okay. So this is a table that I mistakenly forgot to add, and I'm going to add it so you can see it. But it's called the standard normal distribution. And again, if you notice here in the picture, we're finding the area to the left. So for our problem, we were looking for negative 1.25. So if you notice right about here, I think you guys can see this. Yes. If you notice, let's see, right here, here's my negative 1.2. And I'm looking for negative 1.25. So what I'm going to do is negative 1.2, here's the 0.5. I'm going to find the point where those two intersect, and it's right there. There's the area under the curve to the left of negative 1.25, because this is negative 1.2, and if you notice here, There's the 0.05, so if I take negative 1.2 like this. This is not 1.2. Here we go. Trying to put this in parentheses. There we go. That's going to give me negative 1.25. This right here, guys, is the area to the left of the curve. So let me stop sharing this piece here with you, and let me come back to my notes one more time. And I apologize for not putting that in your on your folder, but this is how I would do it. And I came up with, I'm going to say it was 0.1056. Okay. Now, there's another way I can do this also, guys, and I can do this using my calculator if I don't want to use the table. Okay. And I'm going to show you how you can do this using the calculator. So I want you to think about this for a minute. I'm looking for the area here. Now remember, this graph goes on and 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 on forever, right? Forever and a day. So I don't have what we call a lower limit. Lower limit because I'm going to the left. There's no lower limit here, but my upper limit is a negative 1.25. So the way I can do this, and I'm going to do this on my calculator, and guys, the calculator that I have on my computer works exactly the same as that calculator app does. So the way I'm going to do this is I'm going to go second, and then I'm going to hit my bars button, and I'm going to show you how I'm going to do this. So let me stop sharing this piece here, and let me come back to my calculator so I can show this with you guys. And let me pull this up. Here we go. Okay, so let me turn it on. I'm going to clear all this business out. I'm going to hit the second button right there, so second, and then I'm going to hit the vars button right here, vars. And I'm going to go to this one here. It's called Normalcdf. Okay? And it's going to open up parentheses for me. The first number we said was going to be our lower limit. And because I don't have a lower limit, I'm going all the way to the left. So I want you to think about on the x-axis, guys, or on the number line, if I'm going to the left, I'm looking at numbers like -1, -2, -3, -5, right? I'm keep going, and I want to go forever. So I'm going to go like this, negative, and then I'm just going to put a bunch of 9s. People ask me, how many 9s you got to put? You can put as many as you want. I wouldn't just put 1. I would at least put 2 or 3. And then I'm going to do a comma, and then on my upper limit. So the number where we were stopping at was a negative 1.25. And I'm going to close my parentheses here. And I'm going to hit enter. And if you notice, to 4 decimal places, I came up with 0.1056, which is exactly the same number we came up with using that table, right? So I'm going to upload the table because I forgot to upload it for you guys. And I'm going to send it to you guys again in the class announcement and all that kind of good stuff. But you basically have options in how you're doing this. If you want to use your calculator, this is how you do it. If you want to use the table, that's how we did it there, right? So let me stop sharing this piece here, and let me come back to my notes. And let's see, here we go. And again, like I said, guys, we came up with the same number here. So number 7 is doing the same thing. It says, find the cumulative area that corresponds to a z-score of 2.15. So look, here's 2. 2.15 is going to be, I don't know, somewhere right about here. And again, we're finding the area to the left, right? So guys, just a heads up here. If you remember the area to the left of 0 was going to be 0.5, and because I'm going more, I already know my answer is going to be more than 0.5, right? It's going to have to be more than 0.5. So I'm going to show you again 2 ways doing this, on the calculator and on the table, okay? So let me show you how to do this first on the table. And what is we right here? And I'm going to go to 2.15. So if you notice, my z values here are all negative. And I want 2.15. So here's 2.1. Oops. Here's 2.1. And here is my 0.5. So my answer is going to be 0.9842, right? Oops. Let's see if I can get this to work. Right there. 0.9842. And let's see, let me stop sharing this. Come back to my calculator. And I'm going to do the same thing I did before, right? So I'm going to go second in bars. I'm going to go to normal CDF. Remember, my lower limit is negative with a whole bunch of nines. And then comma, 2.15 and 0.9842, right? So I'm hoping that that part seems kind of easy enough to figure out like how to do this on my calculator or how to do this using the table. So 0.9842, oops, 42. Now, if you look at the next problem, number 8, it says find the area under the standard normal curve to the right of negative 1.05. I'm looking for the area to the right. Okay. So if I do that same thing, where I go normal CDF, right? Now remember, this is my lower limit, and my upper limit goes on and on forever. So my lower limit is going to be 1.05. My upper limit will be a ton of nines, right? And so, guys, if any of your, if any of y'all have your calculator, you can definitely do this. So, Perla, do you got a question for me?
Yes. You know how on the previous question you put the negative 99 first, and on this one you put 99 after.
At the end.
Is there a difference?
Yeah, and I'm going to show you. Why I did it that way. So if you notice here, guys, the number I came up with is a 0.8531. So let me stop sharing this 0.8531, and let me come back to my notes, and I want to explain why I did that. So very good question. Just to give you a heads up, we came up with 0.8531. All right. So what's the difference in the problem that we just did and this one? So if you notice in the problem we did before, guys, we were stopping here. We were finding the area to the left of 2.15. But for number 8, we're finding the area to the, oops, that's not how you spell the word right. To the right of negative 1.05. So I'm starting from here and I'm working this way, right? So this is my lower limit and my upper limit is at positive 9999, right? So that's why I have to do it that way. That's the reason why I'm having to go from the 1.05 to the ton of nines compared to the negative 9999 and 2.15, because I'm starting off all the way over here, and this is where I stop, right? Does that make any sense on how I was able to kind of figure that part out?
Yes, thank you.
Yeah, we're good. Okay, so guys, I'm going to show you the same problem again using the table. And again, it's up to you on deciding, do you like the calculator better? Do you like the table better? It's really entirely up to you. Now, the one thing I want to mention is that when I'm doing this on my table always tells me the area to the left of a particular number. Okay, it always tells me the area to the left. So if I were to come back and use my table and go to the negative 1.05, let me stop sharing this. Let me come back to the table one more time. Where's my table? It's right here. Okay, and we said it was a negative 1.05, so I'm going to keep scrolling. Here we go. So negative 1.05 is this number right here. And that, excuse me, and that number is a 1.469. So I'm going to stop sharing this here, right? And I'm going to come back to my notes. And the number that I came up with was a 0.10, 1569. I think that's what it was. 1569. Let me just double check. 1469. Let's see. Here we go. So the area, so using my table, the answer that I came up with was 0.1469. What that actually told us what was the area over here. Guys, if you remember, the area under the entire curve is always equal to the number 1. So if I were to say, well, what's 1 minus 0.1469? We would come up with 0.8531. The only difference is when you're using the table, you always have to remember that the table always tells you what's the area to the left of the curve, okay? It's always going to tell you the area to the left of the curve. All righty, so let's see. Let's do number 9 here, and it says find the area under the standard normal curve. And I want you all to notice here, guys, it says to the right of 2.50. Okay, to the right of 2.50. So here's 2.50. And I'm looking for the area to the right. Look at how small that little red area is. It's a really tiny amount. So I know that when I do this, whether I'm using my calculator or whether I'm using my table, I know that the answer I'm going to get should be pretty small, right? So I'm going to go normal, CDF. Now remember, I'm finding the area to the right. Look what we're starting off at. We're starting off at 250. And because we're going all the way to the right, this is when I'm going to use my 9s, okay? And so let me do this again on my calculator so you can see how I'm doing this. Again, guys, if you have that app on your phone or your iPad or whatever, it's going to work exactly the same way, okay? So you're going to go second, you're going to hit the bars button, and it's going to be the second one, normal CDF, okay? And we said we're going to go 2.50, and then comma, and again, I usually do at least 4 9s. You can do more. And then, like we said, it's going to be a really small number. Look what it is, 0.0062. So let me stop sharing this. Let me come back to my notes. And we said that our answer here, was 0.0062. And there we go, right? So number 10, I'm going to do this exactly the same way, guys. We're finding the area between negative 1.25 and a 0.65. So look, I know my two limits. Negative 1.25 and a 0.65. So just like I did before, I'm going to go normal, CDF, and I'm going to hit a negative 1.25 and then a 0.65. And let's see, question. Okay, so Thomas, you said the first time it was confusing. What about now? Does it seem to be a little bit better now? Much clearer. Excellent. Good. Perfect. I'm glad it's working. Excellent. Excellent. And guys, that's my fault. I completely dropped the ball. Completely forgot to include those tables. I'm going to go ahead and update that part again. And like I said, I'll resend the last message that I sent you guys. I think it was Tuesday, that had the like the formula sheet. I'm going to put the tables in there too. And this way, y'all have options. Jennifer, I see you have your hand up. You got a question for me?
Sir, can you show me the step for the calculator?
Mm-hmm. So I'm going to show you on this one here, okay? So okay, so I'm going to stop sharing this, and I'm going to pull out the calculator again, so you can see this here. And guys, I want to show you something. When I'm doing this here, you're going to, if you have that graph in Calc 83, it's going to work exactly the same way. I'm going to clear my screen. So first thing you're going to do, Jennifer, you're going to hit the second button. So hit second, and you're going to hit that button that says VARs. And is your number 2 say normal CDF? Right there, that second one, you're going to go to that, and you're going to hit enter. And I think the numbers that we had, let me check the numbers we had, was a negative 1.25. So I'm going to go negative 1.25. comma.
Or sorry, second and then what?
Second and then bars. So look, let me show you again. I'm gonna go second.
Bars.
Do you see right here, bars, V-A-R-S? Do you see it?
Oh, where?
So let me see. Give me one quick second. Okay, so I'm doing this here. Okay, do you see it right here? It's right next to the clear button. V-A-R.
Okay, I see it.
Yeah. Okay, you're gonna hit that one, and then you're gonna scroll down to the second one. It says normal CDF.
Okay, got it.
Okay, and then hit enter for me. And then the first number we had, Jennifer, was a negative 1.25, comma. And then the second number we had was a positive 0.65. You don't have to put a plus, just make sure you don't put a negative. And then hit enter, or close it off, and then hit enter. And are you coming up with 0.6365?
What? -1. Yes.
Very good, very good. You got it. And it's good. Like I said, are you using that same calculator app that I was using?
Yes, I'm using the calculator app.
Good, good. Let's see. Okay, excellent. So Thomas says he was confused about where do you put the upper and the lower limits. He understands it now. Excellent. So guys, it's really up to you. You know, like, so when I taught this in the fall of 19, and this was obviously pre-COVID, just before COVID, right? It was we got hit a year ago, and this was the fall right before that. But the class that I had met 2 days a week, and it met from 7 p.m. to 10 p.m. So when I've taught the late classes in the day, like the night classes, I typically have older students, and so a lot of the older students liked using the table because, you know, it was just more familiar with them. They were more familiar with the table than using the calculator. But as we started going more and more, a lot of them became more familiar with the calculator. And it really, like I said, it's entirely up to you. You're always going to get the same answer. You know, so it's really up to you to decide which one you find is, or which one you think is better, okay, or easier for you to use. So let me come back to my notes. I'm glad you guys are asking me these questions because they're coming in really, really handy. And we said something like 0.6365. I think that was the answer that we all came up with. Okay, and so I'll tell you what, guys. Look, I want y'all to do me a favor. Yes, a favor. So if you have your calculator with you, you're going to go normal, CDF, oops, CDF. And remember, my lower limit, negative 1.5. My upper limit, positive 1.5, because we are finding the area in the middle, right? So I'm going to do the same thing on my calculator. I have it both on my phone and on my iPad, so I'll do it here on my phone. Second in bars, normal CDF, negative 1.5, comma 1.5. And let's see, I heard somebody put something in the chat. So let's chickadee check. There you go, 0.8663. You got it, take it away, like Johnny Canales says. So very good, guys. 0.8683. Excellent, very good. So my pen freezes a lot, guys, so sorry about that. Okay, excellent, good. To me, chapter 5, guys, a lot of it, honestly, is doing calculator work, okay? So let me scroll a little bit further. Okay, this is a good problem that we're going to do right here. And I like this problem because it helps you kind of figure out what's happening. So it says, in the next section, we're going to learn how to use the area under the curve for a given value of z. Is actually the probability that z is less than that z-score. And it says, for example, since the area to the left of z equals negative 0.99 is 0.1611, then the probability that z is less than 0.99 is equal to 0.1611. Transforming non-standard normal distributions to z-scores will help determine the probabilities of certain events. Okay, so it says, refer to problem 4 regarding the scaled test scores for the New York State grade English tests are normally distributed. What's the probability that a student chosen at random scored less than a 640 on the test? Okay, so I'm going to show you what I mean by that. Let's see. If you remember, guys, this was the same problem that we had done earlier. Remember when we found our average? We said, look, this here was 650. So I kind of guessed, and I said, well, that number there was 655, right? And I said my inflection point was right about here, which was 630. So when I was trying to find the distance here, and that's my sigma, I said my sigma was going to be 655 minus 630. That gave me a standard deviation of 25. Okay. Now, what we're going to do now is we're going to start by finding the corresponding z-score of the value of 640. Okay. So guys, all I'm doing here is rewriting the formula for how to convert a value to a z-score. Okay. So the x value that I'm concerned with right now is 640. So I'm going to put a 640 right here, minus, remember what we said our mean was? Our mean was a 655 all over my standard deviation, which ended up being 25. Okay. So guys, I'm going to show you how to do this piece on the calculator. So the one thing I want to mention, when you're doing this on the calculator, the best thing to do, honestly, is, oh, come on, pen, put this guy in parentheses, okay? So let me stop sharing this, and let me come back to my calculator. There we go. Okay. And let me turn it on. Okay, so I'm going to put parentheses, and I think I had 640 minus 655, close off my parentheses, and we're dividing everything by 25. Guys, it's important to do the parentheses here, because if you don't, what your calculator will do is going to say, what's 655 divided by 25? Whatever that answer is, subtract it from 640. And you're not trying to do that. You're trying to do the subtraction part first. Okay, so if you notice here, I came up with the number z equals negative 0.6. So let me stop sharing this, and I'm going to come back to my notes, and we came up with the value negative 0.6, okay? What we're trying to do now is, if you look at the problem, it says, what was the probability that a student chosen at random scored less than 640? So what we're saying is, what's the probability that x, my score, is less than 640? In essence, what we've done, guys, is we've converted this part here to a z value. So what we're saying now is, what's the probability that z is less than a negative 0.6? So I'm going to come over here, and because it's less, that means I'm looking for the area to the left of my curve, okay? So now I want to show you something. Remember, we're going to go normal, CDF, right? Now, let me clean this mess up a little bit. Okay, we're using this value here of negative 0.6, and I'm looking for the area to the left of it, okay? Guys, does anybody know what my lower limit and my upper limit are going to be? So here's my lower, and here's my upper. And what I want you to do is look at the picture. What's my lower limit if it's all the way to the left? Anybody know? You can put it in or you can speak it up. I think I heard somebody put something. So my lower limit, there you go, excellent. The negative with a whole bunch of nines, right? Perfect. Negative 9,999. Okay, and what about our upper limit? Anybody know our upper limit?
Negative 0.6.
Excellent, perfect. Negative 0.6. Okay, so guys, we're going to use our calculator. So let me walk you all through that process again to make sure everybody's good with how to do this on the calculator. I just want to make sure we're all on the same page, guys. So I'm going to come back to my calculator. Here it is. And let me clear this out. So remember, again, I'm going to come back over here. I'm going to hit second. And then the vars, but remember the vars is right next to clear, vars. Normalcdf. And negative with a bunch of nines, comma, negative 0.6. And we're going to hit enter. And we're coming up with our answer. Guys, just to give you a heads up, on all these problems here, we're going to go to 4 decimal places. I think that's exactly how my lab is asking you to do it. So if I go to 4 decimal places, I'm going to put 0.2743 because the number after the 2 is a 5, so I need to run that 2 to a 3. So 0.2743. Let me stop sharing this, and let me come back to my notes. And so we're going to say the probability that z is less than 0.6 or negative 0.6 is 0.2743. And that's the same thing as saying that the probability that the score was less than 640 is a 0.2743. Excuse me. So what we're able to do here is find those probabilities using the standard normal curve, okay? And it doesn't matter what kind of problem we have, we just convert everything to z-scores, and then we can do that part, okay? So, guys, I'll give you a heads up. 5.2 is, in essence, a whole bunch of problems just like this last one that we did right now, okay? So we're just on about a time, about 4 minutes left. I'll tell you what, why don't we do at least the first problem here, and then, and I'll let you guys go after that, but I want to at least walk you through problem number 1. So again, what we're going to do here, we're going to convert these so that we can do this problem just like we did the last problem on 5.1, okay? So 5.2 says the average speed of vehicles traveling on a stretch of highway is 67. Okay, so average speed, that's telling me that my mu is 67. Standard deviation is 3.5. So my sigma is 3.5. And it says a vehicle is selected at random. What's the probability that it is violating the speed limit of 70 miles an hour? Okay, so this is what I'm going to do. I want you to think about this expression right here. Violating the speed of 70 miles an hour. Do you think violating the speed means I'm going more than 70 or less than 70? If I'm violating the speed of 70 miles an hour. Anybody know? More, less? More, right? Excellent, perfect, good. So what that's telling me is that right here I'm going to put x is greater than 70. Now what we're going to do, guys, the first step we're going to do, we're going to convert our x value to a z-score, okay? So my x value in this case, 70 miles an hour. My mu in this case we said was 67, and our sigma we said was 3.5. So remember, when I do this on my calculator, and I'm just going to do this, I'm not going to pull up my calculator right now, guys. I'm just going to do this here on my calculator. So I'm going to go 70 minus 67 in parentheses, and then divided by a 3.5. And I'm coming up with 0.8571. So for the z values, guys, the z values are always going to be 2 decimal places. Okay, the probabilities will be 4, but the z-values itself will be 2 decimal places. So what we're going to do now is we're going to say, look, the probability that x is greater than 70 is saying the same thing that the probability of z being greater than a 0.86. So what I'm going to do now, just to give you a heads up, because I think a picture helps out a whole lot. Okay? So remember, in my standard normal curve, my mean is 0. The value that I'm looking at is a 0.86, right? So if here's 1, and here's 2, and here's 3, a 0.86 is going to be right about here. Okay. And because we're looking for z to be greater than 0.86, that means that what I'm really trying to find is what is the area to the right of that curve? Okay, what's the area to the right of that curve? So the area to the right of that curve, I'm going to use my normal CDF, and I'm just going to look at my picture, right? So when I look at my picture here, guys, right, and I'm finding the area to the right of 0.86, remember I'm going to have a lower limit and an upper limit. So my lower limit should be a 0.86, and my upper limit should be 99999. So when I go to my calculator, let me pull that up for you guys. Go right here and turn it on. Again, I'm going to go normal, or second bars, I'm sorry, and normal CDF, and a 0.86, comma, and then a whole bunch of 9s. And so these values are the ones where I'm going to do 4 decimal places. So 0.1949 would be my answer, right? So stop sharing this, and I'll come back to my notes, and I'm going to say that my answer here, the probability that z is greater than 0.86 is a 0.1949. I think that's what we came up with right now. And let me just double check. Yes, 0.1949, and we're done, right? So all these problems that you have here, guys, in 5.2 are the same types of problems, okay? They're the same types of problems that you're going to be doing, like we did with number 12 and like this one here. They're all going to be the same sorts, okay? So let's see. We're just out about time. I'm going to stop sharing that with you guys. And I'm going to go ahead and stop recording too.